So far this morning, we've seen how RIO is evolving to better meet the needs of industry. But the next RIO innovation we're about to showcase is poised to incite a revolution in student design. You know, when I'm not strutting around a keynote stage, using every trick in the book to mask my nerves, which I am doing, by the way, then I'm actually part of NI's academic program. I'm one of several engineers based in the UK who are dedicated to supporting the wonderful world of academia. And as such, I am passionate about enabling students to gain a hands-on learning experience, to actually put theory into practice, and to actually do engineering. Not only do I believe this will inspire and secure the next waves of British and Irish engineers, but I believe that it will arm them with the practical skills that they need to innovate from day one of their careers. And seeing as pretty much everyone in this room is either, employing these students, training these students, or is indeed a student themselves, then I'm sure it's a vision that we can all get behind. And you know what? It works. So this year, the University of Leeds told us how they performed a full curriculum reform, integrating NI's industrially relevant tools to make their courses more practical than ever before. And in doing so, they boosted student employability by a whopping 19%. And it doesn't end there. If you're a student engineer looking to join the launch team at SpaceX, and frankly, why wouldn't you, then they're asking for awesome LabVIEW developers, and they're certainly not the only ones. So, to introduce us to how RIO is evolving to meet the needs of education and student project work, we've actually flown our academic product marketing manager over from blistering hot Texas into blustery November London. So please, ladies and gentlemen, give a very warm British welcome to Margaret Barrett.
Good morning. At NI, we take our commitment to education very seriously, not just with our outreach programs and our philanthropy, but with actual investment in R&D. And our unique approach has been to take our world-class, industry-grade tools and make them available to the classroom. We've actually been doing this for several years. Back in 2004, we introduced a product called NIElvis, and this revolutionized the laboratory, combining 12 instruments into just a single product. And then a few years later, we started thinking it'd be pretty great if students could take engineering home with them. So we made NI myDAQ, which is based on industry standard, but allows students to do engineering in the dorm, in the park, and I'm gonna say it, even the pub. And a year later, we came out with something called the Universal Software Radio Peripheral, which actually transforms a desktop PC into an RF prototyping station.
Yeah, these technologies have been hugely successful, having been adopted by 1,500 universities worldwide, and they're used in everything from basic introductions to engineering, all the way through to master's level design projects and beyond.
That's right. We're actually at it again, though, and this time we are unleashing the LabVIEW RIO architecture on students. All right, well, I am so excited to be here today to announce NI myRIO, our brand new product for students. When we were designing myRIO, we wanted it to be based on the latest industry technology so that students would be learning on the very thing they're going to see when they graduate. But one very important thing we know about students is they get a very short amount of time to complete a project. So we knew we had to create a product that would allow students to design real systems fast. Now, when we were thinking about this, we thought a lot about final year design courses, but also the classes that students take leading up to final year design. Things like embedded systems, controls, robotics, mechatronics. And we took these as inspiration for the features of myRIO. So we knew that myRIO needed to have a lot of I/O, and it needed to have I/O that was ready to use out of the box, but could also be reconfigured using LabVIEW FPGA if an application required it. We also wanted myRIO to be based on the latest and greatest from industry. So we use the zinc chip, the same technology in our brand new compact RIO, so students will be absolutely assured that they'll see this again when they graduate. We also knew that myRIO needed to be very easy to connect to and needed to be able to interact with modern technology. And of course, if students were ever going to take this out of the lab, needed to be in a case and able to be fit into a backpack.
Yeah, good stuff. Well, I've got more good news. So to demonstrate myRIO to us this morning, we've actually got a returning guest. So anyone who was with us last year will probably remember that we used NI tools to instrument up a Ferrari, which was then driven around a test track by NI's tame racing driver. Well, I'm pleased to say that using myRIO, we've upgraded him to give him a very 21st century makeover. So please, ladies and gentlemen, welcome to stage NI's tame racing driver, V2. Thanks very much for joining us, V2, but please show some respect and greet the good people of the audience.
Awesome. Well, we can see that the display reacts to hand gestures. So V2, can you show us what else you've got? Awesome. Well, the display is able to react to hand gestures because myRIO is actually continuously acquiring analog signals from flex sensors on a repurposed Nintendo Power Glove.
Retro gaming goodness. Say, V2, just while I'm kind of keen to ensure that this keynote's running to schedule, I don't suppose you got the time on you, perchance?
All right.
Good man. Yeah, perfect. Say, one last request then, V2. Just while Margaret talks us through this demo, could you put yourself into some kind of a standby mode? Yeah, perfect.
Awesome. All right, well, this demo was developed by an electronics engineering student, and he programmed it so that images are downloaded onto the onboard memory of myRIO and are then dissected by algorithms running on the onboard processor, producing this nice LED color map. But to control the LEDs themselves, he implemented a custom protocol engine right on the myRIO FPGA. And this engine processes the color map and produces a stream of digital bits that are understood by the LED controller.
Cool. I mean, there's no question about it, Margaret. This is a technically accomplished and super, super cool demo system. But at first glance, there doesn't appear to be any kind of real-world usage.
Oh, well, actually, Rich, if you think about it, because he embedded this custom protocol engine on the FPGA, this is really acting as a translator. It's taking meaningful messages and translating it into the native digital language of the target device. In this case, pretty cool LED controller.
Cool, and I guess that's a pretty common use case in industry.
You got it.
So, yeah, on that note, touche, Margaret. Consider me told.
Well, in anticipation of the launch of NI myRIO, we were able to run an early access program, which produced some really awesome demos like this, but also produced some great stories from leading professors about how they feel they can use myRIO to better teach their students. So for instance, at the University of California, Berkeley, Dr. Edward Lee, who's very well known in embedded systems, is actually going to be teaching his own students embedded systems this semester using myRIO, leveraging both LabVIEW and the ability to program myRIO in C with Eclipse. And also at Rice University, for the very first time in this control lab, students will be completely on their own, hands-on programming their control algorithms and achieving very fast loop rates with a device that was made just for them.
Wonderful. Yeah, if you haven't already guessed it, ladies and gents, we're really excited about the potential of myRIO, and we cannot wait to see what students do with this remarkable technology. So on that note, big thank you, Margaret, and of course to V2.